what does the neurochemistry of the placebo and nocebo effects look like? Because I don't think I'll never not be fascinated by that phenomenon actually being tracked like neurochemically.
Definitely. So, what many people imagine, especially when talking about placebo, nocebo in humans, that it's completely psychological phenomenon and there is nothing in the body that changes. But also, what I find the most fascinating about the whole phenomenon is that we do see changes, physiological changes, and I think the chemical processes really are linked to the type of placebo nocebo we're talking about. And the most what we know comes from pain research. And what we see that from animal studies, from brain imaging studies, and from pharmacological studies. So there's a lot of evidence that when a person experiences placebo effect in pain, our brain produces endogenous opioids. So, what happens actually in response to the expectation or the stimulus or the treatment, our brain starts producing our internal endogenous painkillers. And due to this endogenous opioid release, the pain goes down. And that was also confirmed in animal research. And then for the nocebo effect, it's more complicated, and especially for humans because there is not much research done. But one chemical we could track in nocebo effect is cholecytokinin. And our study at McGill also showed that cholecytokinin is involved in nocebo. And when we block this neurotransmitter in the brain, then animals do not experience nocebo effect.
Right. And could you just give us a bit more context as to what cholecystokinin or CCK does?
Yeah, so that's, I think it's very interesting. It's a hormone and neurotransmitter, and we know it initially from the research on digestion. So it's like not related to pain at all, and it seemed even not to be related much to brain because we have lots of cholecytokinin receptors in the digestive tract, and they do signal when you are hungry or when you're full. However, later on, so that was known for a long, long time. But then later on, researchers discovered that there is a lot of CCK receptors in the brain, and it wasn't really clear what they're doing there. And further on, like in the recent years, it became clearer that they also seem to be involved in, for example, anxiety and panic. And there are studies on in humans when people get an injection of CCK that they might experience panic attacks. So it seems to have several functions as many other neurotransmitters, and one of the functions might be anxiety. And that's why maybe it is related to nocebo because probably nocebo to a large extent is caused by anxiety or fear.
Right. And so basically, just to sum it up, when you increase CCK, the anxiety and negative expectations go up, and when you decrease it or block it, the anxiety goes away. Now, just
Exactly.
to create some, I guess, distinction, is how different is CCK compared to a general anti-anxiety medication like Ativan or Xanax or anything like that? Like, could those also reverse the nocebo effect?
Good question. So there is no, so that's why we don't know much about CCK in humans because there's almost no drugs that are can be used in humans to block CCK. There was one drug that has been used in some research, Proglamid, and but it's a drug initially made for digestion, and nowadays it's not used. And the drugs that are can precisely target receptors in the brain, they are not approved for human use. So we do not know whether if these drugs will ever be approved or developed in the way that they're safe for people. Maybe they could be used also for anxiety, but we don't know that. And then talking about using some other anti-anxiety drugs for blocking nocebo, there is actually research on that, and there is, I think, actually only one study that showed that anti-anxiety drug can block nocebo effect in humans, but it was
Okay.
just also one study.
Okay. And what might be the, I guess, intimation that CCK might be having a greater role in the nocebo conditioning than like reversing GABA, which is what the anti-anxiety medications do.
What we look, I think it's different mechanisms, right? And we compared that in our animal models, and then we did not find any effects of anti-anxiety medication on
Mm-hmm.
nocebo in mice, even though there is one study in humans that did find the effect. But also we should consider difference between animals and humans, because in humans it's indeed the nocebo effect might be more cognitive, and it might evoke more general feelings of anxiety that maybe by blocking that, going via that route, might work for humans. But when we look in the animal model, it seems that CCKs really plays the major role, because when we block CCK in animals, nocebo effect disappears completely, so we don't see anything.
Okay. Awesome. And how can one block the placebo effect?
Blocking placebo effect. I'm not sure if anyone tried to do that, because it seems clinically we want to maintain it more.
Right.
Yes, but we can. It's been done for just to look into brain mechanisms of that. So what has been done is there is a naloxone, a drug that blocks opioid receptors, and that's how actually it was proposed that endogenous opioid is involved in placebo. So you can evoke placebo effect with different procedures, for example, giving verbal suggestions or conditioning. And then if you give a person or you give an animal naloxone that blocks their endogenous opioids, placebo effect disappears. So we know that that was how we actually learned that endogenous opioids play a role. So potentially, if you want to block placebo, you can use naloxone.